So you now have to finish answering this question. And there are two ways to calculate that expectation. First method is to use the expectation of the original random variable and using the linear relationship between x and y. And the second method is to make a new probability distribution table for the new random variable y and recalculate the probability weighted outcomes. And let's take the first method first. We calculated the expected number of trips and it was zero point 0.6. And also we know it is easy for each trip. The cost is $1,000. So the total spending is 1,000 times per trip times the number of trips. So it's simply 1,000 times x. So if I don't go to the Disney World, then spending will be zero, of course. But if I go once, then it will be 1,000. If I go twice, then it will be 2,000. So the relationship is quite clear, simple, and it's linear, as you see. It's multiplication of 1,000 plus adding 0. So simple linear relationship. And then plug in the original expectation into the place of x. So replace x with expectation of x. Then you get 1,000 times zero point 0.6, which is 6,000. So it is the expected total spending. And it makes sense. So for each trip, it costs $1,000, but I expected zero point 0.6 trips. So one trip $1,000, then zero point 0.6 trips equals $600. So that's the expected total spending. Okay, this is the easier way, but you may take the full do the work from the beginning. First, transform x into y. 0 is converted to 0, 1 converted into $1,000, 2 converted into $2,000. And probabilities are the same. They are because these two events are the same events. Going to Disney World twice is the same event as I spend $2,000 on Disney World. So they are the same events. So the probability must be the same. And then calculate the weighted outcome for y. Now we are calculating expectation for y. So multiply y, outcome for y, and probability. So you get these three numbers. Then again, you have $600. That's simple. Of course, the result is the same as before, as they should be. So it would be nice if you can double check. If you want a double check in this kind of question, you may try both and see if they are the same. If they are the same, then your answer is safe, and otherwise, you have to uh, think what is wrong, or if there was an error, or if you misunderstood something. Anyhow, it was a simple exercise, and I am going to um, make a twist on this example. So now make it a little more interesting. Now I was I was looking for I was planning my like financial making a financial plan for Disney World, but fortunately I could find a discount ticket. It's on eBay. So on eBay there was a Disney World ticket at a discounted price and say $700 instead of 1,000. But the problem is at the moment I don't know if I'm going. I may not go. I may not be able to go to Disney World. In that case, if I can't go to Disney World, then I'm simply losing $700, right? If I buy the ticket here, but if I go, then I can save. In addition, I make this assumption: if I go to Disney World twice, then of course the second trip will be at the regular price. So you understand the situation. Now I have to decide whether to buy this ticket or not. It may not be available tomorrow, so I have to calculate, do the math right now. I will define another new random variable z as the total spending when I buy this ticket. If I buy $700 ticket, then of course the total spending has to be recalculated, and I'm going to call this z, a new random variable z. And what I'm saying here implies these transformations. So even if I don't go to Disney World, still my spending is $700. If I go once, then it's only $700. But if I go twice, then the second trip should be at the regular price, so $1,000 for the second trip. And given these numbers, calculate now the new expected spending on Disney World. You may use the expected number of trips was zero point 0.6. You may use that or you may not use that. So try this. I will see you in the next video. It may take a little more time, so make sure you try this.